All right, so we're going to work through the warm-up first. This is the geometric sequence and series we added on to, God bless you, 3, sorry, equations, God bless you, yesterday, which was the nth term if it's geometric. A sub n equals a sub 1 times r to the n minus 1. Then we had the sum of a finite geometric series, and that is let me put S equals a1 times 1 minus r to the n over 1 minus r. And then the last one was the sum of the infinite, which can only be done if the absolute value of r is less than 1, meaning it's got to be a fraction or a decimal in between 0 and 1. And that is S equals a sub 1 over 1 minus r. So those three, in addition to, which we'll talk about again in a little bit, in addition to the arithmetic ones, are what you'll need to know for your quiz. So number 1 said write the first 5 terms of the geometric sequence. All I have to do is take that 6, multiply it times a half. I get 3, 3, multiply it times a half. I get 3 halves. 3 halves multiplied by a half. 3 fourths. Oh, sorry, it is negative. Negative, that's negative. Negative, that's positive. Negative, that's negative. And then negative 3 fourths times negative 1 half, which is 3/8. And then we list them in the order of 1, 2, 3, 4, 5, not necessarily in order of its size. You want to make sure you start with the first one they gave you, which is 6, 3, negative 3, sorry. 3 halves, negative 3 fourths, and 3/8. So those are the 5 terms, the first 5 terms in that sequence. Yep.
For the difference between geometric and arithmetic is when it's like addition and subtraction.
Correct.
And geometric is
Multiplication. Yep. All right, write the first 5 terms of the geometric sequence, find the common ratio, and write the nth term of the sequence as a function of n. So there's 3 parts of this. The first part is finding the first 5 terms, and this originally starts as recursive, but it's also telling you it's geometric, right? So I would do 120 times 1/2, which is 60, then 60 times 1/2, which is 30, 30 times 1/2, which is 15, and 15 times 1/2, which is 15 over 2, or 7.5. You could write it any way you want. So the 5 terms are 120, 60, 30, 15, and 15 over 2, or 7.5.
For a question like this, where it's pretty basic multiplication, can you just write 120, 60, 30, 15, 15?
Sure, yeah. Then comes find the common ratio. So what's happening each time is we're dividing by 2, right? Which is the same thing as multiplying by 1/2. So the r is 1/2. And then the last part is finding the common ratio. So a sub n equals a1 times r to the n minus 1. A1 was 120. R is 1/2 to the n minus 1. And there's your equation for a sub n. What could happen after this is it says then find the 10th term, for example. And so then you're plugging in 10 there. Jason.
When the problem is moved like this, is r always going to be the term before a sub k?
If it's geometric, yeah. If it's geometric and recursive, yes. As long as there's nothing added or subtracted. Yeah, no, it's always going to be multiplication for geometric, yeah. All right, then number 3 says use the formula from number 2 to find the nth terms. That's what I was just talking about. Now I'm going to find A10. So I'm going to do 120 times 1/2, 10 minus 1. That's 120 times 1/2 to the 9th. And this is where you got to be careful. Don't let your calculator change that into a decimal for you. I know what 1 to the 9th is. All you have to do is 2 to the 9th, and you get 512. So this becomes 120 times 1 over 512. Now 120, you can see if it goes into 512. Okay, it's not gonna, but I know that they're both divisible by 2, so I can start there. 512 divided by 2, 256. Divided by 2 here is 60. Then I can divide that by 2, that's 30. That's 128. I can keep going. 1564. So I have 15 over 64. Questions on that one? So again, that's kind of where you got to be careful. Don't let your calculator do too much work for you. That should not have been a decimal. Annika.
Can you zoom out a little bit for the formula?
For the top?
Yeah.
All right, then came the summation. So the first one is a finite sequence. I know this because it starts on it says it in the directions, but it also starts at 1 and stops at 4, so it means it stops, which makes it finite. Okay, so from here, I would say A1 times 1 minus r to the n over 1 minus r. A1 is 12. R is what's being raised to the power, so it's negative 1/2. Number of terms, if I go from 1 to 4, would be what? 4. So I would get 12 times 1 minus negative 1/2 to the 4th over 1 minus negative 1/2. And again, be careful how much work you let your calculator do here. So this becomes 12. 1 minus this negative 1/2 raised to the 4th becomes positive because it's an even power, right? And it becomes positive 1/16. So I get 1 minus 1/16 over 1 plus 1/2. Then I need both the numbers in the bottom to become the same denominator. So this becomes 16 over 16, and this becomes 2 over 2. And I get 12 times 15 over 16 over 3 over 2. I'm going to change, flip. 2 goes into 16 8 times, 3 goes into 15 5 times, 12 times 5/8. 4 goes in here twice and 3 times, so I get 15 halves. If you had time and this was like a reasonably small series, you could always check this. I could plug in 1, plug in 2, plug in 3, plug in 4, add them together, and see if I get 15 over 2. It's just not always that easy. All right, and then number 5, find the sum of the infinite geometric sequence. Again, this can only be done if the number that's being raised to the power, which in this case is r, is in between 0 and 1 when you take the absolute value, so don't worry about the sign. In this case, it is. So I would get that A1 is 6, r is 1/3, and the sum of the infinite is A1 over 1 minus r, 6 over 1 minus 1/3. This becomes 3/3. 6 over 2/3, change, flip, and I get 9. Questions on that one? So I would say tricks, like I said it yesterday, but remember if the 6 wasn't there, that a sub 1 is 1, so be careful there. Some people make that mistake. Questions from the homework? Okay, so B here said find the indicated term of the geometric sequence algebraically. So the first thing you have to do is, you had to figure out a sub n, right? Well, what did you do, Chislin, to get a sub n, a sub 8? Did you figure out the equation?
Yeah.
Okay, so an would be 18 times 4/3 n minus 1, right? And then you did 8?
Yeah.
What if you didn't do it like that?
How did you do it?
Multiply it 8 times?
Oh, I mean, that works unless they ask for a sub n. So this time you have to do 4 to the 7th. And 3 to the 7th. And then see if it can be simplified.
Oh my gosh, you know what I did? Instead of 16384, I wrote 16304.
Oh, that sucks.
Yeah.
Yep, just be really careful.
How do you do it with the graphical calculator?
So,
Just put my number from B.
you'd have to put it in as like it's a graph, and then go to the table. That's what it means by table feature. you literally would find your a sub n, like that equation, and then put this in as though it's a graph. And then go to your table and look for the 8th term. Obviously, you're not going to have that on your, yeah.
Use Z like we did today.
So I think, what is this, 9 goes into here and into here, the 243. That's how you get that. Okay, 7, find the indicated term. So again, we have to set up, but this time there's a jump, right? So we talked about yesterday, if there's a jump, I could go largest one on the left, small one on the right, and then the exponent on the r has to make that jump. So what's the exponent on the r have to be? So then I'd get 135 over 8 equals 5 times r to the 3rd. Divide both sides by 5, which is multiplying by a 5th. That would be 27. I'd get 27 over 8 equals r to the 3rd. Cube root. The cube root of 27 is 3. The cube root of 8 is 2. Now I have the r. So to find the 8th term, I could do a sub 8 on the left. I could do a sub 1, or I could do a sub 4. R would have to be to the 4th, or if I did a8, a1, it'd be r to the 7th. Either way, you can plug it in. A8 would be a4, which was 135 over 8. 3 halves to the 4th. That's 81, 16. Which is that 10,935 over 128. Yep.
Because you just said the n minus 1. I did the an.
N minus 1 and plugged in 8. Yep, sure.
On the review, there's a find the indicated term like this one, except it doesn't give you the A1, it gives you A397.
It doesn't matter. You go 7, 3, R has to be to the 4th. So whatever base is, right, if there's a jump, if they don't give you A1 and the R, right, if there's a jump, you put the larger base on the left, the small base on the right, the exponent on the R has to be the number you would have to add to the one on the right to get the one on the left. So if I gave you A10 and A2, then it has to be R to the 8th. That's all. So you can jump however many you want as long as this makes up that jump.
Okay.
Yep.
In this like problem, like a to the 7th is smaller than a to the 3rd.
It just means that R is going to be a fraction, so it makes it smaller. Yeah.
So then would I put the...
No, you still always put the larger one on the left, the larger number base.
Oh, okay.
Yes. Okay, this one is summation to write the sum. So we need in summation for geometric, we need an A1, we need a 1 minus R, we need an N, and we need the 1 minus R again. So I've got the A1, that's 2. And we don't know, well, we can figure out R, but we don't know the N, okay? R would be, how do I get from 2 to 6 and 6 to 18? That's 3, right? But we got to figure out what N is. So I work my way backwards, okay? If this is AN and this is A1, and I know, well, let me plug it in. I know R is 3. What I don't know is N minus 1. So I divide both sides by 2. 8, 7. And then I'd have to figure out what power of 3, 2,187 is. So 3 is going to go into here. 7, 2, 9. 3 goes into there. 2, 4, 3. 3 goes into there. 81, 9 and 9, 3 and 3, 3 and 3. There are 1, 2, 3, 4, 5, 6, 7 threes, which means 7 equals N minus 1 and N equals 8. Now I can plug it in here. So 2, 1 minus 3 to the 8. These cancel, but the sign's still there, so it becomes a positive 650. Or, sorry, 6,560. Oh, wait, what did it ask for? It wanted the summation. Oh, it just wanted the, I'm so dumb. It just wanted the equation.
Did that whole thing.
That's okay. Yeah.
Which equation?
It wanted, no, it says 8 is the answer. Oh, it gave you, right? It gave you this. Did it give you that? And it wanted the number at the top. All it wanted to know is how many terms were in there. We did a lot of extra work. We did the summation, but all it needed was n. Okay. It's good practice to plug it back in. All it wanted was that top part.
And then what do you put in the?
So the answer is 8 because it wanted the number of terms, which goes at the top. So it gave you whatever, n equals 1, and it was looking for this.
And it was also looking for the thing on the side.
Oh, okay.
On the side is what I got.
The thing on the side is the equation to find a sub n, which was this. So you were making the summation problem. Does that make sense? You were making this part. Started at 1, stopped at 8, and it's the summation of a sub n, which is a sub 1, 2, times r to the n minus 1. So it wanted to know what it was making this, like what the a sub n would be.
If you click practice another version, it like shows you like what it wants for the answer.
Okay. It's like trying to help you out. Well, especially now, right? Or yesterday I did that too.
Yeah, 'cause,
Yeah.
like, I clicked practice another version.
And it tried to walk you through it.
Another number.
All right, 12 says find the sum of the infinite geometric series if possible. So again, we have to make sure that this number is a number between 0 and 1. And it's not. 3 over 2 is bigger than 1, which means it's impossible. I think all of them were like that, right? Yeah. All right, this is the calculator, one of the calculators for sure that you can't use because there's summation here. Okay? So you need to find a scientific calculator that does not have the summation on it. Let's see how much we can. I'm going to talk about topics. You tell me if I need to work them out. How about we'll do that? Okay, and then I can post the completed notes later. So 8-1 was sequences and summations. Okay, this was your general sequence. So there was no formulas here. You were just plugging things in, and then at this point we were just trying to figure out summation. So this is find the first 5 terms of the sequence. Assume that n begins with 1. Are we good with how to do this? I would plug in 1. I would plug in 2. I would plug in 3. I would plug in 4. I would plug in 5.
Yes.
Yes? Okay.
The answers like bounce around though, because it's weird. So like the answers like
They're not always going to be smallest to largest, largest to smallest. Yeah, no, that's never going to. So that's totally normal. Yeah. The second one just jumps directly to the 4th term. So I would just say A4 here, and I'd get 4/3 to the 4th, right? This is what you want to be super careful on. You do not want to be putting that in the calculator, getting a decimal, and giving me the answer. The very top thing on your quiz says every answer must be left exact. Routed answers will be marked wrong. Even if you're on the right track, you need to make sure that you're using it to help you in a specific way, but not go crazy. So this, I would do 4 to the 4th, which is, what is that, 256, 3 to the 4th, 81, and I would leave it like that as long as it can't be simplified, which it can. Okay, then find the first 4 terms of the sequence defined recursively. Remember, recursively relies upon the one that comes before it. So A2 would be, I'm going to plug it in here, 2 times A1, which was 5 minus 3. Whatever I get from that, I would plug into the A3. And then when you list your answers, biggest mistake here is not remembering the first one that was given to you. Make sure that's part of your set. We good on that? Yes? Then came summation, and this is straight up summation. So this is summation of any kind of series. That can be something raised to a power. That can be something multiplied. That can be something added. So it's not a specific type of series. And for these, I'm not going to give you a ton of terms, but you are going to have to plug them in and then add them together. So I would plug in 2, I would plug in 3, and I would plug in 4 here. Remember, we start at that number and stop at this one. So it'd be 3 times 2, it'd be 3 times 3, 3 times 4, 6, 9, 12. And then I'm going to add them together at the end to get one answer. Yep.
Did you say that the top number was like how many?
No, the top number is only how many if the bottom number is 1. The top number is your upper bound. Yep.
You don't have to add 2. This time equals 2.
I plugged in 2. You have to plug in the numbers from the bottom to the numbers at the top. So I plug in 2, I plug in 3, I plug in 4, and then I add them all together.
What did you say?
If the bottom number is 1, then I'm going from 1 to 4, there would be 4 terms. If the bottom number is not 1, then remember it's top minus bottom plus 1 number of terms. So if you're trying to figure out how many terms are in a set, it's the upper bound minus the lower bound plus 1. So it would be 4, no. It would be 4 minus 2, which is 2, plus 1, which is 3. Look, there's 1, 2, 3 terms. Okay? If the bottom number is 1, then it is the same as the top number. But if the bottom number is not 1, then it's the top number minus the bottom number plus 1. All right, then we got to factorial. So what I do not want to see you do is figure out what 5 factorial is and 8 factorial is and then simplify it. Remember, you want to take the bigger, break it down till you hit the smaller. So 8 would be 8 times 7 times 6 times 5 factorial. Under 5 factorial, those are going to cancel. And then I just have to do 8 times 7 times 6. And I'd get 1 over 336.
That's all you need for that.
Yep.
That's not bad.
Yeah. Factorials right now, you're just learning the foundation of. We use them a lot when we get to probabilities. Yes. All right, then came arithmetic sequences and partial sums. Now we're talking about a sequence that you add the same number to in order to get to the same one. Now that number can be positive or negative, which would mean you're technically subtracting, okay? But it would be the same number.
So sorry.
That's
But
okay.
5 times 7 times 6, it's just not, is it 1 over that?
Yes.
Oh, okay. Okay, cool.
Okay, so write the first 5 terms of the sequence. Determine whether the sequence is arithmetic. If so, find the common difference. So I'm going to plug in 1, 2, 3, 4, 5. I'd get 4 minus 2 times 1 minus 1. 4 minus 2 times 2 minus 1. 4 minus 2 times 3 minus 1. 4 minus 2 times 4 minus 1. And 4 minus 2 times 5 minus 1. And I think I did this example because here's what super smart people do. They go 2 times 0, 0. Is that right?
Or yeah.
No.
No. What do you got to do first?
No.
Parentheses, yes? 4 minus 2 times 0. Do I do 4 minus 2 first? No. So I don't know why super smart people do this because that's wrong. Okay? It's something that like happens all the time. This would be 4 minus 0, which is 4. You got to do the parentheses first, right? So 4 minus 2 times 1, 4 minus 2, which is 2. 4 minus 2 times 2, 4 minus 4. 4 minus 2 times 3, 4 minus 6. And 4 minus 2 times 4, 4 minus 8. So my terms are 4, 2, 0, negative 2, negative 4. Second part of the question said determine whether the sequence is arithmetic. Am I adding the same number to each of these terms to get to the next?
Yes.
Yes. What am I adding?
Negative.
Negative 2. So D is negative 2. And then find the common difference. That's what we just did. Okay? So it's a yes. And it's find the common difference. Make sure you're reading your instructions. Don't miss points because you didn't answer part of it. Okay? There's a lot with like a multi-part. So you would need all of this as your answer. Good on that one? Yeah?
Yeah.
All right, find the formula for A. Find the formula A. This should be A sub n. For the arithmetic sequence. So this is the first of the formulas you have to know. Which is the nth term of an arithmetic sequence. So I would get A sub n equals A sub 1 plus a negative 4 times n minus 1. I'm going to distribute the negative 4 and combine my like terms. You want to get it as simplified as possible if you're giving it as an answer, which would be that. Then it could say find the 10th term, and you're just plugging in 10. Okay, it says write the first 5 terms of the arithmetic sequence. That means we're going to add. So I'm going to take A2 would be negative 3 plus 12. 9. A3, 9 plus 12. And keep going until I've got my 4 terms. 5. And then the first one is your fifth. So negative 3, 9, 12, or sorry, 21. And the other. Next one says, use the finite arithmetic sum formula to find the sum. So here's the next sum of arithmetic. Is S equals N over 2 times first plus last. So sum of arithmetic, N over 2, where N is the number of terms, first plus last. So, you're leaving? All right, so what's the first term in the first 25 consecutive positive integers? 1. What's the last term in the first 25 consecutive integers?
25.
How many numbers are in the first 25 consecutive integers? 25. Yeah, because you start at 1, right? The last one is the number. Does that make sense? If it goes 5 to 25, that's when we have to do 25 minus 5 plus 1, right? Okay. Yeah. If it starts at 1, the last number is the number of terms. If it does, because you would be doing 25 minus 1, which is 24, plus 1, which is 25. If you're trying to figure out the number of terms in a sequence, it's the last term minus the first term plus 1. But if it starts at 1, you don't have to do that. It is the last term. Okay, so partial sum here, I would take, this is, I don't want to plug 1 in, then 2, then 3, then 4, then 5, all the way up to 120, right? You'd be there all day. So this is arithmetic, which means I'm going to do n being 120 because the bottom number is 1 over 2 times the first. If I took 1 and plugged it in, I'd get 3. The last, if I take a 120, plug it in, I get 360. And then I'd get 60 times 363. That's the wrong answer. 21, yep, I did 18, yeah. 21, 7,080. Okay, good on that one. So, terms over 2, first plus last. All right, then we end with how we started the day, which is your geometric sequences and summation. So, some of this was not on the warm-up. I'm going to kind of try to go faster through the other ones. So determine the sequence is geometric. I'm looking to see if I divide this number by this number, is it the same as this number by this number and this number by this number? Test every single one, because if the first 2 are fine, but then the last one's not, it's a no. So I want to do 0.32 divided by 0.8. Obviously they're negative, so they're all negative. And that's 0.4. 0.128 divided by 0.32. Also 0.4, 0.0512 divided by 0.128, also 0.4. So this is yes. R is 0.4. Second one says find the first 5 terms of the geometric sequence and write the expression for the nth term. So I would just multiply. I would do negative 5 times 2/5. That answer times 2/5. That answer times 2/5 until I get to my 5th term. And then the indicated term, so the nth term is another equation you got to know. A1 times r to the n minus 1. This is the nth term of geometric. Which in this case would be negative 5 times 2/5 to the n minus 1. And then if it asked for a specific term, okay, if it said to give me the 10th term, then I would take 10 and plug it in. So it would say, like, 10th term. Now I'm taking 10 and plugging it in. And keeping it a fraction. Questions on that one? All right, then these are the ones that we're throwing you because they're the jump ones, right? So A7 goes on the left. A3 goes on the right. R, what do we have to be raised to? The fourth to make up the difference. So A7, which is 80 over 27, goes on the left. A3, which is 15, goes on the right. R to the fourth. I'm going to divide both sides by 15 or multiply by 1/15. This is 3, 16. 16 over 81. And then I got to find the fourth root. So I find the fourth root of 16 and the fourth root of 81. The fourth root of 16 is 2. The fourth root of 81 is 3. And there's R. Now I need to go back to, if I want to go to 10, you could use either one, but if I did A7, it would be A10, R to the third. I could go back to the original equation. I could go back to A3 being on the left. The original equation, I just don't have A1. Wait, I switched those. Sorry, hang on, A10. Yeah, A10, A7, R3. So A10 is what I don't know. A7 is 80 over 27, R 2/3 to the third power. So 80 over 27 times 8 over 27, 640 over, whatever 27 squared is. 729. Yep.
If you multiply 2 over 3 by 15, like 4 times until you get to 7, it doesn't work.
2 over 3 times 15, 4 times. For sure. You could also work with A3. So you can do A10 on the left, A3 on the right, R to the 7th. Yep, you can do it either way. All right, then it's the sum, right? So finite's going to have a number at the top. Infinite's going to have the infinity symbol at the top. Finite, we do the A1 times 1 minus R to the n over 1 minus R. That's the, what are we on? 1, 2, 3, fourth equation you need. So this is geometric finite sum. And then infinite, which is that next one, A sub 1 over 1 minus R. And again, that one can only be done if R is a fraction between 0 and 1. So on this one, whoops, a daisy. This one can't be done. And if it says state y, R, absolute value of R, is not less than 1. So for this one up here, A sub 1 is negative 3. 1 minus R is 1/4. N is 6 because the bottom number is 1 and the top number 6. Over 1 minus 1/4. And then you would raise 1/4 to the 6, really just a 4 to the 6th. Find the least common denominator, subtract them both the top and the bottom, and simplify it as much as you can. The one on the right, A sub 1 is 1 because there's nothing here. 1 minus 2/3. And then find the least common denominator, simplify it, keep, change, flip.